Let's take a look at problem number 1 from exercise 722. I'm going to do a couple of examples for you just so you kind of see what we're looking for in each one. So in number 1, we want to first identify what our leading term is. So that's going to be what has the highest exponent. So here's your constant. We've got a second degree and a third degree term. So this right here would be our leading term. If we wrote this in standard form, it would be f of x equals negative 4x cubed plus 2x squared plus 3. So in this leading term, we're looking at two things. We want to look at the coefficient, which is a negative 4, and then the degree, which this power of 3 makes it a degree 3. So it has an odd degree. It's going to have an odd degree behavior. Whoops, wrong one. And then it has a negative leading coefficient. So if it has an odd degree and a negative leading coefficient, that means that it's going to start up here and it's going to end down here. And that's really all we care about when we're determining if it's, or we're determining its end behavior. Okay, we won't necessarily worry about even and odd function today because that takes a little bit more in-depth explanation. We'll cover that once I'm back. So you can just leave this line blank for each one. Don't mark it out because we will come back and do it, but you don't have to worry about that. So we're going to answer about our end behavior. So this says as x approaches positive infinity. So here's our x-axis. So as we go to the right, as x is approaching positive infinity, what's happening to our y values? Okay, so here those y values are going down. So we would say f of x, or y, another name for f of x, goes towards negative infinity. That's all that's asking you. Okay, and then as x approaches negative infinity, so as our x's go to the left towards negative infinity, what's happening to your y's? And over here they are going up. So we would say they approach positive infinity. Okay. And then the other one I wanted to look at is one where we can just go to number 9, okay? One where it's not necessarily in standard form. So to determine your leading coefficient, you don't necessarily have to multiply out this whole thing into standard form. We can simply multiply these two things together, multiply all of your first terms for each binomial together. So this one only has 2, which becomes 6n squared. And then we do have this negative out in front. So for this one, my leading term is negative 6n squared, making it a degree 2. Leading coefficient is negative 6. So a quadratic that has a negative leading term is going to look like this in terms of the end behavior. Okay, so really all we care about is this and this. Okay, so we would say as x is going towards positive infinity, so as we're traveling to the right, my y's are going down towards negative infinity. And then as x is going to negative infinity, my y's are also going towards negative infinity. So for both of these end behaviors, we would say they are going towards negative infinity. End behavior is going to be an even end behavior since that leading term had the n squared. Once again, we're not going to worry about whether the function is even or odd. We just talk about the end behavior being based on an even parent function.